Um, hi everyone, I'm Jordan. I'm hopeful that this one's a little bit more kind of conversational as we go through rather than me just kind of spouting stuff at you. So today I want to talk about why enterprise teams need to care about API lifecycle. And if we're honest, like no one cares about API lifecycle typically. It's not a subject you get up in the morning and you go, hey, I want to care about API lifecycle today, right? So I'm hopeful that by the end of this discussion workshop that we have, you will have a bit more understanding of why API lifecycle kind of matters and some of the cool things, some of the cool outcomes that you can get from having a well-defined API lifecycle. So this here is a really good outcome of having a well-defined API lifecycle. Has anyone heard of Newman? Hands up if you've heard of Newman. Yeah, so Newman is Postman's collection runner. So if you've configured some requests in Postman and you've added some tests to those requests in Postman, you can run them in Postman as well, and it'll report on that. But most of the time you don't want to do that. Most of the time you want your test to be executed as part of some CI build process. Newman is the tool that you use to execute those tests. And in this particular one here, we've executed a set of tests, and it's run 360. All 360 have passed. There've been none that have been failed or skipped, and it took 47 seconds to run it, which is kind of cool. The cooler thing is I didn't write a single one of those tests. Those tests were all auto-generated off an API spec, okay? And it looks something like this. So essentially, I go into Postman and I can click Run this collection. And what it's going to do is go and get my OpenAPI spec, and it's going to analyze that spec for all of the requests that are in there, and it's going to make live API requests in real time to all of the different possible endpoints and all of the different permutations of those endpoints as we go. And as you can see, it's generated 360 tests, and I've reported on that in Newman. This is an outcome of having a well-defined API lifecycle because you are starting with an OpenAPI spec. And the spec is now being used to generate lots of other information, documentation, tests, mocks, all of the different things that you need as part of your service. I think a lot of people are still in the kind of the mindset of OpenAPI spec. We might use that as part of a design process, and then we kind of forget about it, and then we go move into code later, right? There are other kind of frames of mind where we might not even use it at all, right? Like we would write our code and then generate our OpenAPI specs off the code and hope that they kind of marry up in the end. So hopefully today what I want to do is talk a bit about the value of having OpenAPI up front and then going from there. The second big benefit that you can get once you've got your OpenAPI specs and you're using something like Postman to publicize them is using API networks. I have so many conversations with people in enterprise that have no idea how to find APIs within their organization, right? Something as simple as like an address validation API, yeah? Imagine if you had the ability to go to a place like a private API network that contained every single API asset within your organization, and you could type in here address validation, and you could see that, yeah, sure, 6 months ago, someone from another team across the other side of my organization launched an address validation API, and I can use that today. You know, it's crazy that enterprise teams don't do this for a lot of the time. They're just left to their own devices. So essentially what I'm trying to say is understanding your API lifecycle creates clarity within the work that you're doing. It makes it easier to test, it makes it easier to document, it makes it easier to discover. I guess the question that I've got for you is why does clarity matter? What are we trying to achieve here through clarity? And if you think about how many push notifications that you've received on your phone today, maybe not today, you're at a conference today, so you're probably not getting many, but on a normal day, you're getting all sorts of notifications from emails, from Confluence pages, from Jira tickets, from Trello cards, from Zooms, from Google Meets, and I'm at the point now where I get a notification and I swipe it away, and I'm like, I actually needed to read that, but I have no idea what system it came from, so I'm like searching through Jira tickets to see if that's where it came from, or searching through Confluence pages to see where it came from. I just have no idea. And I think it's an aspect of being remote. I mean, we already had these tools. We were using these tools before we became remote. But transitioning to a remote work style feels like it's increased the complexity of work and the complexity of the tools that we're using a lot. And so by like it's also getting worse. I found these stats on the ABS, which I think are really interesting. Like 1.3 million people changed jobs in 2021. It's like as part of the the Great Resignation that happened. 8 out of 10 businesses are reporting not having enough applicants for the jobs that they are putting on the market. They just not finding people to actually join. And so the net result of that is, on average, we're working 5.3 hours of overtime, unpaid overtime each. What this is leading to is a world where smaller teams are expected to produce more and higher quality results. The answer that we get is just do things faster, right? Do more with less. Increase your velocity somehow. I guess, how do we increase velocity? We have a smaller team and we're expected to produce higher quality outcomes. Clarity. API Lifecycle increases clarity. Clarity is the only path that I can see to increasing velocity. If you want me to do things faster, you need to have a clear strategy. If you want me to do things faster, I need clear requirements that don't change. I need clearer quality targets as a QA, so I know what I'm actually testing. I need clear operational metrics as an SRE, so I know what my SLAs and uptime targets are, and so I can work to those. And as a customer, I need clear documentation. The only way that we can work faster is to make things clearer. One other thing that's clear is the time that we're spending on APIs. So this was recently published in the State of the API survey, and I've left the legend off, sorry about that. The orange at the top, bar as the top, is how much time we are currently working on the category, and the yellowish kind of bar is the one that how much time we think we should be working on that particular category. Okay, so we can see that full stack developers in general, are working on coding and programming and APIs almost 30% of their time. And they agree, that's how much they think they should be working on it. But if you think of a third of your week as a developer is spent on coding and programming APIs, it's a large chunk of the work that you're doing. So any optimizations that we can do to that, any clarity that we can introduce to that program is going to result in a net productivity benefit, and it's going to make things a lot better for your organization. And this is where the API lifecycle comes in. So API lifecycle being kind of another take on software development lifecycle, but specifically for APIs. And APIs are interesting in their way because they do have two kind of concurrent life cycles that work together. You've got the producer side, which probably, you're in this room today, so probably the organizations you work for are producing APIs in some way. And so you're going to be following these steps. You're going to be defining and designing your APIs, developing and testing them, securing them, deploying them, understanding how they work from an observability perspective, and distributing them in some way for your consumers to now pick up. You want them to discover them, evaluate whether they're right for the need, integrate them into their world, test that everything's working, deploy their applications, and observe them, which then feeds back to the original API definition process, and the whole process starts again. So the API lifecycle is about creating clarity. That's another stage of it. So if we go to the next level of what the producer lifecycle looks like, each one of these sort of category lines that we've got here is a stage of the producer lifecycle. You've got different owners across each of the lifecycle stages. Now, it may be the same owner across the lot. You might have an API product manager that's doing everything. Or you might be a big enough organization that is able to split the ownership of the API lifecycle across different areas. But ultimately, each one of these stages needs to have someone that's essentially guiding what needs to be done there, and there are going to be some steps in the process that are executed. I think the funny thing about this particular slide, and when I talk to people about this, is that not many people have ever kind of documented this within their own organization. The API lifecycle exists, they just don't know what it is. And the problem with that is that it's done differently for every single team, every single API, every single time we're going through this process. We do it slightly differently every time, which introduces issues with quality, introduces issues with security, introduces issues with observability of these services that we publish out. And so by having this API lifecycle map available to you means that everyone, no matter which team they're working in, no matter what API they're working on, they're all able to know the exact stage of where they're at with their particular APIs and being able to follow the necessary steps along the way. I'll pause there for a sec to see if there's any kind of questions, comments.
About the Open API spec, how how does that work when you're building workflows that are being triggered through APIs where there is no spec? Like, I'm working in a scenario, like I'm in a scenario where the platform we use allows us to engage with that endpoint, but it's not publicly exposed. There's no way for the consumers outside to know that this endpoint is available to them. They don't know what the ins and outs are because the software isn't going to make that public. So we have to kind of write that up ourselves. So how do you work in that space? How do you ensure that you've got that coverage there outside of manually creating your user base outside?
So you're working with a vendor that has not published an open API spec, but they are publishing an API. So
they've given us the software to build something. We build the APIs and the workflows, but it's using the tools, like little modules that they have.
Okay. Yeah, I'm not sure. I might need to see kind of what it is, but like essentially you've got two options in most cases. If they are not providing an open API spec for you to understand what their API structure looks like, what the parameters you can give to it are, and what the expected responses and response codes are, you can either ask them really kindly to give you one, which is kind of the nice thing to do, or you can craft one yourself.
Yeah, because the control's given to us about what that looks like, barring some key fundamentals. But yeah, I've got my laptop with me, so I'll probably show you after.
It'd be an interesting one. So, I mean, look, this is a workshop about Postman, so naturally I'm going to talk a lot about Postman and how Postman kind of fits into this world. But I do have some really cool stuff to show you as part of that, and hopefully that will trigger some interesting conversation, okay? So what I want to go through today in the workshop is showing a few different stages of the API lifecycle within Postman. So I want to pull an open API spec from a local server into Postman. I want to use that to generate a collection for documentation. I want to use that to generate mock servers for testing and show you how a developer and a tester could work together against a mock server in a Postman world. I've got a copy-paste bug there. The third one, is supposed to be contract testing. So the contract testing that I showed you at the start, I want to show you running that in actual practice, and then publishing APIs to the public API network. So showing you kind of define, design, build and test, deploy, operate, and surfacing from there, okay? Please, feel free to ask questions along the way as well. Okay, so where's Postman? It's not working.
Not installed.
Yeah, there it is. Okay, so I'm going to come into this workspace here. So how many people use Postman on a daily basis here? Yeah, so pretty much everyone, okay. So I may be showing you a bunch of stuff that you already know, and if I am, please tell me to speed up a little bit. If not, tell me to slow down. So what I've got is a workspace in Postman, and I've imported a couple of collections into this workspace that I'll show you. I've got a documentation collection. I'm actually going to delete this collection, and because that's a remnant from a previous demo. And this particular open API, what I want to do is get to a point where I have no definition for this API. So this is completely empty, and I don't have any mock servers, I don't have any monitors, so it's relatively empty in here. So the collections that I have in this particular workspace, I've forked from the public API network in Postman. This first one is an open API sync collection that was built by a guy named Nick Schott, who's in my team. And the purpose of this collection is to pull an open API spec from a URL that you provide, bring that open API spec into Postman, and automatically generate a documentation collection off the back of it.
Something like Swagger, as an example? Or?
What do you mean, sorry? So
is something like Swagger?
Like when I say open API spec, is that what you mean? Yeah. So I use the term open API to encompass open API versions 1 through 3.1. When people refer to Swagger, they're often referring to OpenAPI 2. So, I just use the generic term OpenAPI to refer to kind of all of them. But yes, a Swagger definition. So, in this particular case, the OpenAPI specification that I'm trying to pull in is running on localhost. So it's running here, and it's in my views, assets, OpenAPI, schema.yaml directory. This could have been generated from annotations and code. It could have been handwritten, but somehow this OpenAPI spec exists here, and I want to bring it into Postman. And so to do that, I've got two parts. I've got the collection, and I've got the environment. The environment file is this one here, sync with schema. And what it's got is the URL to my local host. It's got my Postman API key and the workspace that I want to import it into, and a couple of other parameters that are needed for this particular collection. And so what I can do is go open APIscene, run the collection. Apparently, what's going on? Run. This is always the thing. And I need to make sure I pick the right environment, the sync from schema environment. And we can go run. And so now if we quickly jump back into this one here, and the run is going, we can see that that API has been imported into this here, and at the same time we can see a documentation collection has been created and added to that. Now this documentation collection is a one-to-one mapping of all of the different endpoints that exist within this particular API. So I can get a list of products from the database that is currently running on localhost port 3000, and I can see that products API there. If you're in the previous session, this is the same API. So essentially what we're doing here is creating this API-first workflow that allows us to pull that in. So now, as that changes are being made, through those annotated code examples, that open API spec will get updated. We can run this collection again, and it will resync that and resync the documentation into Postman and make sure everything stays up to date. Okay, so we're bringing that in and giving us the ability to kind of use that within this environment here. The next thing I kind of want to do, now that we've got a documentation collection available that I can use to see what the API looks like and write up some documentation on that, share that collection with my colleagues or customers, I want to create some of the next kind of stage of the API lifecycle. So when we select the version of the particular API that we're working with in Postman, we get to see the definition of what that particular API looks like. We get to see the documentation of that API with all of the different endpoints that are available for us to use, which tell us about the authentication. The next thing we want to see is some tests. So how do we add tests? Well, what we can do is we can create a new test suite within our particular API. So we'll call this product API tests, and create a test suite here. You'll see this here is another collection. So we've got our products and orders documentation collection, and we've got our test collection, which again mirrors the state of this particular API. Why do we have a separate documentation and a test collection? Maybe a question you ask. The collections are for different purposes. So a documentation collection is intended to be read by someone who's wanting to learn about the API. There will only ever be one instance of each endpoint in that particular collection. You would never duplicate it. Whereas in a tests collection, duplication of endpoints is completely fine. As you're trying to give it different inputs, different outputs, different expected response codes, different, test scenarios, that's what you do in your test collection, right? So your test collection will have all of the different endpoints that you're hoping to achieve, and also the ordering of those endpoints. For example, I'm going to get a list of products from the database. I'm going to create a new one in the database. I'm going to retrieve that specific product. I'm going to update it and delete it. If I had that delete endpoint at the top, that's not going to work in a test run, right? It needs to be sequentially correct in order for this to work. So straight away, what I can do is actually run this collection if I wanted to, but I'm going to start adding some tests first. So by and large, I want this particular endpoint here, which is a return a list of products from the database. If I go to the test tab, I get given these nice little scripts on the right-hand side, which are quick scripts that I can add tests to my API. So the first one is, I want this particular one to return a status code of 200 OK. So I can just click the test that says status code is OK, and it automatically inserts this code for me here. The second one that I want to do is maybe a response time one, which says, the response time is less than 200 milliseconds. Let's be kind to ourselves and make that, 2 seconds or 5 seconds or however long your APIs go for. And as we send that, we can see that our test results down here are passing. So these are the way that we can kind of add these tests. Now, if I'm a QA person, I've generated a open API spec. I've generated a test collection off this. I may not have access to localhost, like this particular example has. Like the testers probably don't have localhost running. Instead, the testers will want to have some kind of mock server running instead. So what I'm going to do off this product API test is, instead of using localhost, I'm going to generate a mock server. So I'm going to mock this collection, products API mock and create a new mock server off that. And what that'll give me is a URL. So I can copy that mock URL, and I'm going to copy that into my mock server environment here. I'm just going to paste it here, and save that. So now as a tester, I don't have access to localhost, so I can't use that particular localhost variable. Instead, what I'm going to do is change my environment to that mock server environment. Mock server looks like that particular URL there, pstmn.io, and I can send that. And, oh yeah, we've got a failure, 500 internal server. Here we go. Ah, yes, okay, so this is an outcome of, I actually raised an issue with the Postman product team on this at the moment. It's returning back this example response here, not this example response. So let me just fix this up for a sec. What I do here is I go status equals 400, save, and question mark status equals 500, and save. And then now when we do the test again, the example is going to come back. So what it's returned here is this example, a list of products. And if I wanted to, add some more products to this, what I can do is come in and edit that and paste a bunch of products in there and click save. And the next time I make that API call, we can see that there's a bunch of products that have been returned back. This is really nice from a tester's perspective. I, as a tester, now get to essentially put the data into the mock server that I want to be there. I can add and manipulate that data as I see fit to accommodate my test cases. I can even use the two other examples that I had before, status equals 400. If I want to trigger a 400, I can see that the 400 response came back. And if I want to trigger a 500, I can do the same thing here and trigger a 500 response back, right? Which is really nice from a tester's perspective. But I think the really nice thing that comes in here is that your testers coming in and they're using validators to validate their code, and they're doing JSON value checks and whatever else. The tester is consistently adding tests to this particular area. When the developer comes into this exact same test collection, because the developer is now building on their local host, the developer can come in and run this test, the same test that the tester is writing, but it can run that against their local host environment and know the tests that have passed or failed.
As they're building that test suite, when you created the collection, it basically had no tests for it. It just effectively just replicated the whole thing and just had a whole clean slate.
Correct.
It was up to the user to actually go into every single test, or every single endpoint, and put in the tests. Now that's, I'm trying to think of an optimization way from here. There could be a lot of work for some people who are time poor, and that could lead to poor quality stuff because someone's decided to, I'll just skip that because it's taking me too much time. I've got bigger things to do. How would you ensure that every single test is at least got some sort of important category, like ensuring that you return the right status code, or ensuring
So the status code is an interesting one because it's going to be different for every single endpoint that you have, right? Depending on the method that's being used.
But the point still stands. How do you ensure that it's pre-populated with something that's actually that's a must rather than a optional?
Yeah. So I mean, you can elevate where your tests exist. So you can test on the method here, or you can test at the folder level with your tests here. So it means every request that exists within that folder will now be subject to that test.
Yeah.
Or you can go even one step higher and say all of the tests within this collection, the requests within this collection should be subject to a particular test. Now, I think this is only relevant when we're talking about response time tests and performance and these types of things that are going to be common across all of it. But doing this does at least have one test across every single endpoint.
Yeah.
I think that when you're writing tests for these endpoints, there's a couple of different types of tests that you want to be running. Functional tests where you're testing, like, does the response contain a certain value, like a specific value? Those have to be manually written. That's the job of a QA engineer. We can't automate a lot of that.
I wouldn't expect that to change either.
But the contract testing, I think, is where the automation can really come into its fold. And so I can show you that now, right? So the second part of this is to say, well, it'd be really nice if we could validate that the implementation, the OpenAPI spec that I have here in my definition actually matches the implementation that I'm running on localhost. I'm a developer, I'm adding new endpoints, those endpoints have got JSON schema, like JSON objects that are coming back. does that actually match the schemas that whoever's designed this spec have got in here? Does it support all of the different required fields? Does it have all of the properties? Are they the right types? All of that kind of thing. Well, so yes, you can do that automatically using the second collection that I've imported from the Postman public API network here, called the OpenAPI Contract Test Generator. And so what this is going to do is exactly what I talked about then. It's going to go and query the OpenAPI spec. It's going to query the endpoint that I give it and make sure that it actually validates and everything kind of lines up. So again, what I'll do is I'll run this against localhost first. So I can run that, and so yes, it's going and getting the OpenAPI spec and querying localhost, and we can see here that it's actually it's right now running hundreds and hundreds of tests against localhost.
Because those would be all the permutations of all those data endpoints.
100%, right? So what we can see here, if I just take a moment, so from I'll go to the product perspective.
Someone's popular.
So the first request that it ran here was a get products endpoint. And the get products has returned to 200, so that's validated. The second one that it ran was a post products endpoint. 201, that means a product has been created in the database. But then it's followed by a whole bunch of 400 bad requests. Mm-hmm. Each one of these 400 bad requests is exactly as you said, it's a permutation of the required fields. On the OpenAPI spec, this particular endpoint have 5 required fields: name, cost, description, ID, whatever they happen to be. What would happen if we removed one of those required fields? Well, we would expect the service to return an error of 400. What if we removed the second one, but left the others? We would still expect a 400. That one, we'd still expect a 400, right? No manual tester is ever going to write all of those permutations of that particular thing. So we have to automate the testing, which is what we see here today.
Because it's been spec'd.
The spec is being validated against the implementation, correct. Not only that, the 201 actually created an object in the database, right? So if we go and look at the particular object, the response that came back from that, we can see that this has an ID of a new product that's been created in the database. And we know that upcoming in our API, we've got a put request. The put request is expecting to update an object. So what object is it going to update? It'd be really nice if it could update the object that we created in the script just before. There we go. That's the ID of the object that we just created. Right, so it's not only, it's captured the ID that it's created and it's passed it into a subsequent request. So it's retrieved that particular object that it's created and validated that all of the properties are correct, and then it's updated that particular object. And then again, it's updated with all of the different permutations and made sure that it errored on every single one. And then the last step, it's deleted it. So it's cleaned up after itself. Nice. Right? So this is a really nice way of using an OpenAPI spec to drive a whole bunch of automated testing behavior. And the beautiful thing about this is it requires no maintenance whatsoever. As long as you keep your spec up to date, your OpenAPI test will work from there, right? So this is an outcome of having a well-defined OpenAPI lifecycle. The last thing I wanted to show you here was around linting. Linting is the process of kind of validating your OpenAPI spec against a series of rules. What are the rules? Well, the rules here, they're written in a language called Spectral. So Spectral looks like this. Anyone who's familiar with JSON schema may know what this kind of looks like. Question, Daniel?
Sorry, does it test the data types?
Yes. Sorry, I did actually want to show one more thing there because I think it's useful to see it failing. So, so what we can see here, so our new product endpoint has all of these required fields, right? It's also saying that the name field is of type string, description of type string, cost. We've got cost as type number. So if I instead make that a string, so my example value of 445 is a string, which doesn't match this particular number, what I would expect to come back is to say, well, actually, because, just to be clear, when it's creating the post request and the put request, it's using the example values from the OpenAPI spec. So it's pulling the examples, constructing an object from that, and sending that. So if I make the example value the wrong type of value, when I run that contract test, and I haven't actually done this before, I haven't practiced it, so I'm just hopeful that this will work, right?
On the spot.
Let's on the spot, right? Like, let's see if creating a new product fails because the data type doesn't match.
Yep, I see fail.
Cool. And not only has one failed, the post has failed, the product ID has failed because there was no product to get, and the put has failed, right? Like, because it was, so it's had some flow-on effects. And the assertion expected data.cost should be a number. So it's pulled that out, right? So it's quite nice. So the linting, this is a process that we want people to start to get into, and it's about trying to set a standard for your open API specifications across your organization. So this is about setting things like all of our cases should be in camel case, and our max lengths of fields should be certain max lengths, and our titles shouldn't be contain certain information, title in kebab case. So by having this kind of standard, you can make sure that the open API specs, no matter where they are created in your organization, follow a certain schema, a process. So the third collection that we've got here does the same thing. It pulls the open API from my workspace, it looks at the default rule set that we've got running here, and it runs a linting process across that. I think that's the environment that I need here, and we can run it. And so it's going to go through its process, get the API, get the rule set, and lint the open API. And then hopefully, as an outcome of this, we get a bunch of linting successes and failures that tell us what's good and what's bad about our API quality, our open API quality. So here we go. So we can see, all of these. So we can see that my info object title needs to be in kebab case. It's telling me there's an error here, there's a failure here, there's a failure here, right? So you would define the rules however you need within your organization, and this would then come and tell you all of the different passes and failures from that, okay? So then these test cases, we can then go and associate with our tests here. So if we go and add our test suites, so what have we've done? We've done our contract generator tests, and we've done our linting tests, which is this one. And we start to now get a visibility over what our API testing looks like within the Postman dashboard here. We can see this API has been tested a bunch of different times. The last time it ran was today at 3:04. If we expand this out, we can see the reports on these different test runs that have been done on this particular API. Okay. From a deployments perspective, we've got plugins to both Apigee X and AWS API Gateway. So if your API is running on API Gateway, you can now monitor from here what this API is looking like. And not only that, you can, if we click on latest here, you can start to see some metrics around latency, around error counts, all this kind of stuff that's being pulled from AWS API Gateway. Which just gives you, again, a kind of a holistic view of your API within one place. You can see everything from definition all the way through to operations in this one particular place. And the last aspect there is monitoring. So we've got our test collection, our Open API contract validator. What we want to do is run that every morning at 9 a.m. and make sure that all the tests pass. So to do that, we would create a new monitor, and we'd use an existing collection, which is this contract test collection. And we're going to say 9 a.m. contract tests, right? And it's going to run every day at 9 a.m. The environment we're going to use is the contract tests localhost environment. Actually, we'll use the AWS environment. We'll contract test the live environment, and we'll create a monitor. And so now every day at 9 a.m. the contract tests are going to run, and we can just kick off a run of that, and we can see what that kind of looks like here. So it's going to prepare the run. I'm expecting that to fail actually, because I think I've got some issues on the AWS environment, but you get the idea.
With these monitors, and if as organisations start to get them running in the background and running routinely, would one want to consider having the instance flushed before you do a new run of a test to ensure that you don't get data sizes outside of the scope? Because one issue I have is that, this probably comes down to how we've implemented it, is that we have an environment, an API endpoint, we basically hit a test point, creates a whole bunch of records, but we're not deleting everything because we have to delete everything that's on the data. So to ensure that we've got a clean slate, you would flush it out. Is that the safest way to do that, by actually ensuring that you flush the system before you do the new run, or is it more, or is there a better practice, a better way of managing?
I guess it depends where you're testing. Like if you're testing against prod and you're validating like whether the environment is up in terms of an operational test, Probably no. Flushing prod before it is probably not a great idea. But if you're testing the QA environment, then that's like a data question, isn't it? Like, what test data are we expecting to exist in the environment before we run our tests?
Yeah, because I was saying QA thing, because you never want to do it on prod, because at least the QA space is the gateway in anyway. It's just more of a case that it's an environment that's live, right?
Yeah.
So therefore, if you hit an endpoint that says, hey, I want to create a record, it's actually going to put a record in the database.
Yes.
So therefore, to take it out, you delete it. But let's say if you had all your permutations that were, some of them were valid, others were invalid, and all the valid ones were created, well then at some point, if you're going to rerun it, you're expecting the data to be flushed out before you run it, right?
Yeah, I think so. And I think that's healthy test data management, right? Making sure that after the end of a test run, things are deleted and the environment's returned to a consistent state. So, we did have a failure here. I'm not entirely sure why, but the thing to take away from this is that this is going to run at every 9 a.m. You're able to get that to run every request that you want it to run and validate all of those different tests. And then the output of this information, sure, you can see it in Postman. You're able to see it here, but also you can start to push it to some of your operational monitoring tools that you're using. So whether you're using New Relic or Datadog, or even if you just want to push some of this to Slack, you can do it there. So if I was to configure, say, Datadog and post the monitoring results in there, I can generate a API key. I think I've already got one actually in Datadog. This one here, copy and paste, and then I can choose the monitor that I want it to run, and I can connect. And then now I've got an integration with Datadog, so every time my monitor runs, it will allow me to go and view the dashboard, view the metrics of that particular run, and I can go ahead and see how my integrations are currently working, how my APIs are currently working, right? So I think I might be out of time, and I think everyone's feeling really tired because it's the end of the conference, the end of the day. But essentially, what I wanted to kind of summarize with, the world we live in is chaotic. We have so many tools, so much technology. I believe that introducing an API lifecycle and developers and testers understanding that API lifecycle and making it clear across the organization will increase the clarity that they have in their day-to-day jobs and allow them to essentially do more with less, right? And Postman as a tool enables that to kind of run. So, hope you enjoyed the workshop today. Thank you very much.